Today we're going to talk about DeMorgans Law. DeMorgans Law was established by a passionate mathematician named Augustus DeMorgan. Now, DeMorgan also gave us the distributive property that we use extensively in algebra and also the commutative law. So he is important for many famous laws that are used in mathematics today. DeMorgan's law is a little more involved, and it has to do with logic and Boolean algebra. It's also used with electronic circuitry. Now here you see the two parts of DeMorgan's law. Basically, it says the negation of a conjunction. So remember, conjunction means and, is the disjunction or the or connectors of two other negations. So it's almost as if, those of you who know the distributive property, it's almost as if that negation symbol will distribute, but the and changes to or. And likewise, if you have the negation of an original or problem, then that is the two separate negations connected with an and. So the negation of a disjunction or is the conjunction and of two negations. Now the way it works in electronic circuitry, there are two different types of gates, and you always want the most direct route for your electronic circuit to get from point A to point B. Thus, it makes our tablets and computers and phones run faster. So they have these gates. There's the AND gate that is one shape, and the OR gate is another shape in the diagrams that they use. Notice the OR has a little bit of concavity here at the bottom. If they had an AND gate, a negated AND gate, you see that NAND, that's equivalent to putting two inverters on an OR gate. You'll notice it drawn out here. These little triangular areas with the circles are called inverters in electronic circuitry. So basically, DeMorgan's law not only works in Boolean algebra in the subfield of logic mathematics, but it's also used for a practical application in anybody who deals with electronics. Now, for our purposes, we want to use DeMorgan's laws to write some statements that are equivalent to each other. So let's go ahead and take a look. In the given statement, it said it is not true, so that is a negation. So it is not true that frogs and fish both have fins. So I'm going to put the and symbol here for our conjunction. Notice that I'm talking about frogs, fish, so I'm going to put PQ. So I'll have the negation of P and Q. It is not true that frogs and fish both have fins. According to DeMorgan's law, I should be able to rewrite that, and it logically makes sense and be true if I rewrite that as not P or not Q. So let's see if we can find a sentence that looks like that. In my answer choice A, it says frogs do not have fins, so that would be not P, and fish do not have fins. Well, that would not be the correct answer because the and did not change to or. Remember, according to DeMorgan's law, if I start with an and, I have to have an or. Notice in my second choice, it was an if-then statement. That is not true. Now I will see that I do have two or statements in my choices for C and D. In choice C, that is frogs have fins, so that's P, and then fish have fins, that's Q. So I would have P or Q. That has nothing to do with the negation. So my final choice must be the correct answer. Frogs do not have fins would be symbolically written as not P. The word or uses the disjunction or symbol, and then fish do not have fins would be written as not Q. That is the correct answer. Let's try DeMorgan's law with one more example. It is not the case, so that's my negation, that it is still summer or there is frost on the pumpkin. Remember, the word or must change into an and situation. So it is not the case that P, it is still summer, or Q, there is frost on the pumpkin. That will be written as not P, which would be not summer, and not Q, which would mean not frost on the pumpkin. So the first thing I'm going to do to make this a little bit quicker problem is look for an and, because if I start with an or and I'm converting that with DeMorgans Law, then I have to have an and. This first example has an or, so it would not be an answer choice. My last example uses if then, so that would not be an appropriate answer choice. I also need negation. So I need the word not listed twice since I'm converting this. If you look closely at answer choice C, it has not summer, not frost. So that means not summer would be not P, and is the conjunction symbol, not frost would be not Q. So my answer choice is C. I hope this helped you understand a little more about DeMorgans laws.